There's a lot going on in this question. I'm first of all gonna get a bigger diagram and then start like adding in some of the key information. We've got that the square has sides of length 2, so I'm going to put a 2 there, and also an area of the shaded region is 2. And we have that the radius of the circle is also 2. Now what I'm going to do is go from the center to the where the circle meets the square. That tends to be quite a good idea because it's like linking the two shapes together somewhat. And if I do the same the other side, then this is 2. I can actually form a triangle. And not just any triangle, this is going to be an equilateral triangle. So all the angles are going to be 60 degrees. And if I now make a line coming down, I can even look at the height of that triangle. And I can also make this 30 degrees, that angle there. I'm going to focus on half of the equilateral triangle then, this bit in green. So all the way across is 2. This is the halfway point, so this length is 1. And I can use Pythagoras' theorem to work out this missing length. It's going to be 2 squared minus 1 squared square rooted, which is going to be root 3. So I've now also got the height of this triangle. And we've got that angle. So what I can do now is head towards finding this area here. And it's going to be the area of the sector that we have. So 60 over 360 times pi times 2 squared minus the area of the equilateral triangle. And I can just do half base times height here. Half times root 3 times 2, because it's the whole thing I'm doing now. I could use a half AB sine C as an alternative, but it'll give me the same answer. It doesn't matter. The half and the 2 are going to cancel. The 0 here is going to cancel with this. And the 6 and the 36 is that's going to cancel just to leave me 6. And then I've got 4 over 6, so it's going to be 2/3 pi minus root 3. Okay, so that is that shaded area. But that's really good now, and we're actually nearly there. Because don't forget, we have this distance here as x. Because what that means is that this distance is going to be that root 3 minus x. So I can basically now use the area of the square. The area of the square, or actually the area of the shaded region, is equal to 2, but it is also equal to 4, which is the area of the whole square, and then I need to minus root 3 minus x, that's the height, times 2. And then I need to also minus this purple area, 2/3 pi minus root 3. That needs to be in a bracket. I'm just going to say that one more time. Like I'm just going to kind of go through the whole steps again. So I've drawn some lines in to construct an equilateral triangle, spotted that, angle 60 here. Split it up into this green triangle. Now have the angle to give 30 and also got the height of this green triangle using Pythagoras. Found this purple area of this segment by doing the area of a sector minus the area of this equilateral triangle, which gave me this bit here. And now I'm using the fact that I've got the shaded area is 2, but the shaded area can also be found by taking the area of the whole triangle, subtracting the area of this rectangle here with base 2 and height root 3 minus x, that's what I did here, and then minusing the area of this segment. So now I've got an equation in terms of x. Remember, I'm trying to work out x. So we can sort this out. So it's going to be 4 minus 2 root 3 plus 2x by multiplying this bracket out, and minusing 2/3 pi, adding root 3, because there's a negative and a negative here, and that is going to equal 2. I can tidy this up. Actually, I'm going to just leave it. So I've got 2x on the left-hand side. Then I'm going to minus the 2 by 4 to give me minus 2. I'm going to do root 3 minus 2 root 3, which is minus root 3, and add that to both sides to give me plus root 3 over here. And then I'm going to add the 2/3 pi. And finally, I just need to divide through by 2, and I'm going to put the minus at the end. So I'll write the pi first. It's going to be 1/3 pi plus root 3 over 2 minus 1. 1/3 pi plus root 3 over 2 minus 1. And that's our answer A. Well done.